So let's get the ball rolling. So hello, welcome. So good to have you. Today we're going to be looking at an introduction to organic chemistry. When you hear about organic chemistry, I'm going to ask a few of you what comes to mind. So what comes to mind when you hear about organic chemistry, Karel? Karel, we don't want any pauses, so just keep it flowing. Karel? All right, Carl is not there. Bronte, what comes to mind when you hear about organic chemistry? Bronte? All right, not hearing Bronte. What about Javon? What comes to mind when you hear organic chemistry?
Um, the structure, makeup of certain things, and like Jessica said, compounds, properties, and so forth.
Okay, so organic chemistry, even the persons are gonna watch this replay, you can tell us what comes to mind when you hear organic chemistry. So organic chemistry is essentially is the chemistry of compounds, so that's very good. So it's the chemistry of compounds which contain carbon, and carbon, that means it's an organic compound, right? So the study of compounds that contain carbon, which would be organic compounds. Now, most of these compound students also contain hydrogen, and many of them contain oxygen and or other elements. So they can contain hydrogen, they can contain oxygen, or even other elements such as your nitrogen when you start talking about your proteins and your amines. But for now, we're looking at compounds that essentially are made up of carbon. So sometimes we oftentimes interchange carbon chemistry for organic chemistry or organic chemistry for carbon chemistry. So I want you to follow along with what I just sent you in the group. Now, organic compounds. Now, the structure of carbon is as such that the carbon has a valency of 4, right? True me talk or lie me tell? What's the valency of carbon? Wanna not talk to me.
Yes,
All
Miss
right.
Rina.
What's the valency of carbon?
It's four, right?
4. Perfect. It means that it has, well, it needs to either lose 4 or gain 4 electrons to become stable. So 4 electrons, that's the valency of carbon, right? Or share 4 electrons. It could also share, which is what it really does. It doesn't lose, it doesn't gain, it shares. So it undergoes covalent bonding. No, it has a valency of 4 and normally forms covalent bonds. So I'm looking at the first page. Example of this popular trend being in practice is your methane, which is CH4. What that means is that 4 hydrogens are bonded to 1 carbon. 4 hydrogens bonded to 1 carbon because this 1 carbon needs 4 electrons. So it needs to share 4 electrons. So each hydrogen needs to share 1. So 1, 2, 3, 4. And this comes together, 1 carbon, 4 hydrogens to form methane. Have you guys ever seen methane? Heard of methane? Know what methane is? Do you know what methane is? Ever heard of methane? No? All right, so methane is a very popular gas. We use it in cooking, and you're gonna hear more about methane as we go along. Now, the shape of methane is very tetrahedral. Tetrahedral meaning it's as such. I want you to Google what tetrahedral looks like. A tetrahedral form. Look at a tetrahedral shape, right? So look at that for me. In the meantime, now, as a result of carbon having 4 valence electrons, carbon atoms can actually join with each other in an almost unlimited way to form one straight or branch chains of different lengths. So it can keep going. So a carbon can bond with 3 other hydrogens and 1 more carbon, which would bond to another carbon and 2 more hydrogens, which will bond to another carbon and 2 more hydrogens, and it can get as long as possible. That's what we call a straight chain. So if you look at the first diagram on page 125 that we're looking at, that's what a straight chain is. Are you following with me? Jessica, you're following? Ciara, are you following? So that's what a straight chain is. And we have the branch chain, which means it forms branch. You know how you have a tree, guys, and then the tree grows very tall and you say, all right, that's a straight tree, but then you could have a branch tree. So it's essentially the same thing, either straight chain or branch chain. That's how it looks, all right? So the next thing that you want to look at is rings of different sizes. So carbon compounds can also form rings. So you have certain rings such as a benzene, very popular one, but we don't study it in details at this level. So it can form rings of different sizes, right? Example, the one that you're looking at, which is actually a benzene ring. You'll learn about the name soon, right? Now you have the single, double, or triple bonds. That's very important. Please make a note of that. So organic compounds can actually form single, double, or triple bonds. Single bonds meaning you will see that only one little stick there, right? So a carbon would only be bonded to one carbon through one single bond, which means that each of the other carbons would have a possibility of bonding with 3 more hydrogens or 3 more something else, because one of them would be that bond with a carbon. It can form a double bond, which means that instead of only sharing 1 pair of electrons, 2 pairs of electrons are being shared. So carbon double bond. So where you see that double bond right there in the diagram for the double bond, it means that you have 2 pairs of electrons being shared. So one is 2, the other is 2, and then the other 2 single hydrogens on the diagram, follow me with the diagram, would make 4, right? So at all times, carbon can only be bonded to 4 things, 4 other elements. If it's bonded to itself, that's taken as 1. If it's bonded to itself 2 times, that's taken as 2 sets of bonds. Cool? We also have triple bonds, where we have a carbon being bonded to another carbon through 3 pairs of bonds, or 3 bonds. 3 electrons right there are being shared. Are you seeing that? You seeing that?
Yes, ma'am.
All right. And then if we look down more now for the formula of organic compounds, the formula of organic compounds may be written in 4 ways. So we're gonna ask Carol to read one of the ways. So Carol, over to you. One of the ways.
Full structural formula. This shows in 2-dimensional diagrammatic form how the atoms are arranged in one molecule.
Very good. All right. So Javon, second one.
Miss, I'm sorry, but I lost the picture. Oh, I'm on it now. I'm on it now, Miss. Miss, are you referring to the empirical formula? This shows the simplest ratio of atoms of each element present in the compound.
Ciara, third one, the full structural formula.
In 2-dimensional diagrammatic form, all the atoms are arranged in one molecule.
And then the last one, the shortened structural formula. This shows the sequence and arrangement of atoms in one molecule in such a way that the nature and position of attachment of each functional group is shown without actually drawing the molecule. So it's like a shortening it in essentiality. So I'm going to give you a minute to copy those. So copy those, all right? Finish writing those off, so we're ready to pick up now. So example would be the butanoic acid. The molecular formula for butanoic acid is C4H8O2, and then the empirical formula is C2H4O. The full structural formula according to the diagram would be the diagram that you're looking at right now. Are you looking at the diagram? And then if you should shorten it, you're gonna get CH3, CH2, CH2, COOH, which may be shortened further to C3H7, COOH, right? Now, what you're getting from that is that each carbon atom forms 4 bonds with other atoms. Now, each nitrogen atoms form 3 bonds with other atoms, and each oxygen atom forms 2 bonds with other atoms. Now, each hydrogen atom forms 1 bond with another atom. So that's essentially the breakdown of it. We're going to come back to more examples, but this is just a general outline. Any questions that you have so far? Go ahead with your questions. All right, so I'm trying to give you the best in 1 hour. All right, so I see the thumbs up coming in. Perfect. So isomerism, have you ever heard of the word isomerism? When we talk about isomerism, what does that even mean? What word comes to mind when you hear isomerism? Ciara, what word come to mind? Isomerism. All right, so isomerism, I'm going to tell you and I'm also going to type it. Isomerism is the occurrence of 2 or more organic compounds with the same molecular formula but different structural formula. So these compounds are called isomers. So I'm going to share my screen with you and put it there so that you can make a note of what isomerism is all about. So isomerism is the occurrence of 2 or more organic compounds with the same molecular formula, different structural formula. So the compounds are called isomers. Any questions? If you have questions, drop them in the chat. So that's what we really mean by isomerism. So I see 6 messages in the chat. Okay, no problem. So that's what isomerism is, right? So isomerism, let me put that in real life for you. Isomerism is like you have 5 girls and 5 boys in a class, right? And that would be 10 students. It means that you could arrange, so no matter what, you have 10 boys, 10 students, 5 boys, 5 girls in a class. You could arrange them in such a way where you have all 10 students lined out horizontally, or you could take them and put them vertically, or you could put 5 in one row and 5 in the other, or you could have 5 rows of just 2 students each, or you could put 3, then 3, then 3, then 1. At the end of the day, you will have 10 students, but you can flip them around in any particular order. So that's what we really mean by isomers. So it's the same empirical formula, or the same molecular formula rather, but different structural formula. So it's the same molecular formula, but a different structural formula. So at the end of the day, it's just 5 boys and 5 girls, but you are putting them in any order that you feel fit because you're trying to, have a different structure to your class. So, when you're in class and you're giving trouble and your teacher say, all right, I'm going to switch up today. But then they take your friend and they put your friend around at the east and then they put you around at the west. At the end of the day, you guys are still in the same class, but then it's just that there's a different structural formula. Make sense? So if you look at the diagram on 127, that's what it's talking about. So take a look at that, and then we're going to discuss any questions that we have about isomers. Everybody's good with isomers? Talking. I'll do the talking. So functional group. When we talk about functional group, we're talking about the function or the functional part. So each organic compound is made up of two parts. They have the one, the hydrocarbon part, and two, the functional group or groups, right? Which comprise, or this is the part comprising another atom or group of atoms. Now, the reactions of the functional groups determine the chemical properties of the compound. There are different functional groups that we study in chemistry. I'm going to put them out. I'm going to show you. But that's what functional group is all about. So you have the hydrocarbon part, and then the functional group is like the other part, which has another atom or group of atoms, right? And however they react, that determines the chemical formula or chemical properties of these compounds. There's another thing called the homologous series, very important too. Now, the homologous series, organic compounds are classified into distinct groups. So we classify all organic compounds into distinct groups called homologous series. Now, some homologous series include your alkanes, your alkenes, your alkynes, your alcohols, your alkanoic or fatty or carboxylic acids, and your amines. You're gonna hear more about all of these in their individuality or in their respective functions. But just to give you some general properties of the homologous series, I think I sent you up to that. So one, all members contain the same functional group. So make a note of that. All members contain the same functional group. Two, all members have the same general formula. Three, all members show similar chemical properties. What that means is that all alkanes are going to react the same, all alkenes, all alkynes. So it has the same general property. However, the reactivity decreases as the number of carbon atoms per molecule increases. So as you get bigger, then the reactivity changes, right? Now, physical properties show gradation along a series. As the number of carbon atoms per molecule increases, melting point, boiling point, and density increases, as well as the solubility in water would decrease, so the opposite. Next thing, which is number 5, each member differs in molecular formula from the next by CH2. So you keep adding a CH2 group as you go up, because you're adding a carbon and each carbon is gonna come with another H2. Or in relative molecular mass by 14, which would be the mass of the carbon, which is, what's the mass of carbon again? Okay, since you don't know, the mass of carbon is 12, right? And then the mass of 2 hydrogen would be 2. So therefore, that's how we get the 14. Next one, all members may be prepared by similar methods. So you prepare whatever ones you're preparing, they can be prepared by the similar method. All right, now we have different ways how we name straight chain members of a homologous series. Whenever you have one carbon, guys, you call it a meth. That's why you have methane, because there's only one carbon in that alkane group. Eth is for 2. So 1 is for meth, that's 1 METH. Let me use the screen share option. So 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent. So so the total number of carbons will match with the name prefix that we put in front of that. So let me put it up. So number of carbons, if you have 1 carbon, so if you have 1 carbon, the prefix is gonna be meth. If you have 2 carbon, the prefix is going to be different, which is eth. If you have 3 carbons, the prefix is gonna be different, which is prop. If you have 4 carbons, the prefix is gonna be but. And then if you have 5, it's gonna be pent, and it goes right up, but we're just gonna call it 5 for now. So you have to study these, all right? So study the number of carbons and the correct prefix that we use. Now, the first part of the prefix is related to the total number of carbons, or carbon atoms, while the second part is related to the functional group present. So whether it's ane or alkane, is gonna be methane. If it's well, you don't have methane. But if it's an alkene, it's gonna be ethene or propene or butene or pentene. If it's an alkyne, you're gonna have your pentane. If it's an alkanoic acid, you're gonna have your butanoic acid, ethanoic acid, which is vinegar in real life. If it's an amine, you'll have the name, and then the list goes on, and it's like that. All right, so the first part is the prefix, which determines how many carbon, and the second part is related to the functional group present. So it's very important that you record this table that you have here: homologous series, general formula, functional group, naming, example containing 2 carbon atoms. So we have alkane, alkenes, alkynes, alcohols, alkanoic or fatty or carboxylic acids, and we have amines. At this point, I'm going to allow you to copy your table, and I'm going to allow you to ask any questions that you possibly might have. What I want you to do, I want you to rewatch. The video is going to be available for you. You can rewatch, and any questions or anything that you're not clear about, you just let me know. Remember that you have to subscribe to the channel so that you can get updates of when I post new information about chemistry, physics, biology, or just general tips how you can become successful in exams, in school, life after school, college opportunities, scholarships, anything I get, I post them to that channel. So you can subscribe, share them with your friends. So send it to your classmates and tell them that this is an educational site in Jamaica for students who are either in PEP or in high school. Cool? So the next class, we're going to be talking about the hydrocarbons, fractional distillation of crude oil. I want to get oil overall, how we get the alkanes. We're going to zoom in on the alkenes. We're going to look at, so alkanes and alkenes, we're going to zoom in on. We're also going to zoom in on alcohols, alkanoic acids, and esters. All right? Uses of alcohols, all those things we're going to look at. All right, guys? So that's it for today's class. If you have any questions, now is the time to let I know.